Today's lesson is all about discounts and markups, which has a lot to do with real life, okay? Do you think that we are happier when we get a discount or when they mark something up?
A discount.
A discount. Why do we like discounts?
It's cheaper.
It's cheaper, okay? So you're basically getting a better deal. Okay, so when we're talking about a decrease, basically that means it's a decrease in the original price of an item. So the price goes down, which is why we're happy if we get discounts, okay? When is like the biggest discount of the year? Black Friday. There's normally tons of things that go on sale during Black Friday, okay? So basically we're going to use this formula that we've used before, P times F equals is. Here's what you need to understand. The P is the percent that we're actually paying, okay? So let's imagine if you go to the store and it says something is $10, that's 100% of the price. It's $10. If it says this is 20% off, that means we don't have to pay 20% of it. What price are we, or what percentage are we actually paying? If it was 100% and it's giving 20% off, we pay 80%. Okay, so that's where the P, we're going to go ahead and put the percent that we're actually paying, and we'll change that to a decimal. The of is going to be your original price, and the is will be the new price after the discount. So let's just go ahead. We're going to do a few of these problems together. We're basically trying to find the sale price. So what happens is you go into the store, you see the original price of something is $50, but you don't have to pay $50. You're going to get a discount. So when we get our final answer for the sale price, is it going to be bigger or smaller than $50? It's going to be smaller because you got a discount. So now let's go ahead and start with our formula just like we normally would do. P times of equals is. Now remember, when we do the P, or we do the percent, we are going to find the percent we're actually paying. So here's the example, 20% discount. We don't have to pay 20% of it, so what percentage are we paying out of 100%? 80%. We're going to pay 80%. So change 80% to a decimal, which would be 0.8. Now we're going to multiply it times of. If you remember, the of is going to be the original price. What was the original price of this item? $50. It was $50. And that's going to give me my is, which is going to be the sale price, or we'll just go ahead and put an X. When you multiply that out, what is 0.8 times $50? $40. Okay, so now you can see the sale price is going to be $40 instead of $50, which we're typically happy if we get a discount. I want you to do the same exact thing on problem B. Problem B, the original price was $25.60, but we get a discount. We're getting 40% off. So let's start with our formula. What's the formula?
P times of equals is.
Excellent. Now remember, the P, whenever we're finding a discount, we're going to plug in the percentage that we are actually paying. Charbel, if I get a 40% discount off of 100%, what percentage am I paying? 60%. 60%. Change it to a decimal for me.
0.6.
0.6 is correct. Now I'm going to multiply it times my of. Remember, the of is the original price that the item was. Nikki, what was the original price?
The original price was $25.60.
Good job. And that's going to give me my is, which if you remember, we're just going to call it X because that's going to be the sale price. Cameron, what do you get when you multiply 0.6 times $25.60? Okay, so 15.36, what would that be as dollars and cents?
$15.36.
Very good. So now we can see our new price that we're going to be paying after the discount is only $15.36, which is a happier price. Once again, go back and just double check. If I'm getting a discount, make sure that this right here where you end up is going to be smaller than what your original price is. That's just kind of a quick way to double check to see if you're on the right track. Okay, so the next thing we're talking about is a markup. Markup is an increase in the original price of an item in order for the company to make a profit. So let's just imagine that, say, Walmart is going to a huge warehouse. And they go to the warehouse and they see a bunch of bikes. And they know they want to sell some bikes in their store. When they go over there, let's imagine that they pay $50 for a bike. Do you think that when they go back to their Walmart store that they sell that to us as customers for $50?
No.
Why not?
Because they wouldn't get it. Because they want more money.
Okay, they want to make some money. Now let's think about them. At Walmart, they don't just have the cost of purchasing those bikes. They also have to pay an electric bill. They have to make sure that they can pay their employees. So they have some overhead costs that they have to make a profit. How many of you know of any stores that ever closed? They were no longer in business. What store can you think of? Toys R Us didn't make it. Kmart didn't make it, okay? They probably were not able to make a profit. So they have to be able to make a profit, and in order to do that, they have to do this right here. They have to mark it up. So for us to be able to find the markup prices that we're going to need to, we're going to use this same exact formula right here. What's my formula? Okay, P times of equals is. This is a little different here. The percentage is going to be the given percent. So whatever it says, if they say we marked it up by 10%, we're going to go ahead and just change that to a decimal. Now, still, the of is going to be our original price, and the is going to be our new price after the markup. And what we've got to do is make sure that we always add the markup to the original price. So let's do a couple examples for this. Find the selling price here. The cost to the store, they went into a warehouse, they purchased an item for $25. They're not going to sell it for $25. They're going to mark it up by 10%. So should my final answer be bigger or smaller than $25? Bigger, because they marked it up. So let's go ahead and start off with our formula. P times of equals is. We're going to put our percentage, but we have to change it to a decimal. So they marked it up by 10%. Change that to a decimal for me.
1.1.
Just 0.1. It would be 0.10, but we don't need the 0 at the end. Times of. Remember, the of is like the original price. How much did they pay for it? $25. When we multiply these two together, it's going to give me my is, or it's going to give me the new price that I need for my markup. So what is 0.1 times $25?
2.5.
Okay, as money, what is 2.5? $2.50. Okay, because remember, if it says 2.5, you've got to just add that 0 to the end. Now, is the new price $2.50? No. What is that $2.50? That's the markup, okay? So they decided, I am not selling it for $25. I'm going to mark it up by $2.50. So if I'm marking something up, what do you think I need to do to those numbers? Let's add them together. Originally, it was $25 when they bought it. They marked it up by $2.50. Then when you guys add this together, this is going to give you the selling price, or the amount that they are selling it for in the store so they can make a profit. What are they selling it for, class? $27.50. Now, that seems like a fair price. They only marked it up a little bit, but they are still making a profit. They also did all the work. They went to the warehouse. They brought it back. They're paying their employees, paying the electric bills. So it would make sense that they need to do some kind of a markup. All right, let's do another example similar to that. The cost of the store now, they're obviously selling a bigger item, is $150. They've decided to mark it up not just by 10%, but this one they're going to mark it up by 28% so they can make a little bit more of a profit. Let's start off with our formula. Haley, what's the formula?
P times of equals is.
Okay, so we're going to go ahead and write P times of equals is. Remember, when we're doing a markup, we're going to go ahead and put the percentages in exactly as they're given. So, Gianna, it says 28%. What is that as a decimal? 0.28. Now, my of, if you remember, is the original price, or what the cost was to the store. Alexis, what was the cost to the store? All right, they paid $155. Now that's going to give me my is, or that's going to give me what the markup price is going to be. All right, guys, what's my markup? All right, as money, what would it be? $43.40. Okay, now once again, just right next to that, that's the markup. Because a lot of times what people will try to do is they'll say, okay, I got my answer, and they'll box it in. But if you think about it, if it's going to be a markup, you would really want it to be bigger than what the cost to the store was. So that wouldn't make sense. So how do I find what the selling price would be? You add them together. So we're going to add together $155 and add together the markup price that we just found, and this will give us our selling price. All right, Brody, what'd you get? $198.40. Okay, so do you guys see the difference between the way that markups and discounts work? Okay, perfect. We're going to go ahead and move on. We're going to do a few more examples. The original price of a video game is $35, but it's on sale for 25% off of the original price. What is the sale price? Let's go ahead and start off with our formula. P times of equals is. Nehemiah, if we are finding the sale price, what should I put as my percent? Okay, now listen, we don't want to put 0.25 in there because we want to put in the percentage that we're actually paying. If we're getting 25% off, what percentage are we paying? Okay, so we're going to be paying 75%, so instead we'll put a 0.75. Multiply that times the original amount of the game. Nehemiah, what was that? Good job. And then go ahead and help me find what is the sale price. That is correct, $26.25. Now the next question is asking me something a little bit different. This says, what was the discount? So if I know it was $35, but now I only have to pay $26.25, how much money did I get taken off of the actual price? Who can help me figure out how to do that? What would I do, Hunter?
Subtract.
You would subtract. Very good. So you take what the price originally was, it was $35, and take away what we actually paid to find the difference of what kind of a discount we got. Javaria, what'd you get? That is correct. You got $8.75 taken off of what the original price would have been. Next one, the wholesale price of a surfboard is $150. A retail shop marks up the surfboard by 60%. What's the retail price of the surfboard? In the end, is my retail price going to be bigger or smaller than $150? It's going to be bigger. Why? Because they're marking it up, okay? So first, we're going to find the markup. Let's start with our formula. Sierra, what's the formula? Good job. Help me out to know what should I plug into this formula. Okay, very good. We're going to just turn that percentage to a decimal, so we put 0.6.
The O is 150.
Good job. We want to make it multiplied times the cost that they had to pay, and that will give us our markup. Haley, what's the markup? Okay, very good. She got $90. Now, the next part says, find the retail price. How do I find the retail price, William? Okay, what two numbers should I add together? Very good. It was $150. He says to add the markup price to it, and that will give you the retail price, or the price that we as customers would go in and pay. William, what'd you get? It is $240. Okay, so listen, if we go into the store and we see that surfboard, it's $240. But let's just imagine that they decide, hey, I'm going to go ahead and give that person a 10% discount. If they gave us a 10% discount, that would take $24 off of the price, okay? 240 minus 24. So then that would be 216. We go in there and we're thinking, yay, we're getting a discount. I only have to pay $216. But is that company still making a profit? Yes, because they still only paid $150. So they can discount things lower to a point that they as a company would still make a profit. Another example. This one is the original price of a skateboard is $50. The skateboard is on sale for 20% off. What's the sale price? I want you guys to start off by writing your formula, and then I want you to do it with your partner. See if you guys can come up with the answer. I saw a lot of people who did great on this problem, and some people forgot this first step we're going to talk about. The P here, you only want to put the percent that you are paying. remember, you normally have to pay 100% for an item, but you're getting 20% off. So what percentage do you pay? 80%, which is 0.8. Now, the original price was $50. So guys, what was our sale?
$40.
It was $40. So you got to pay $40 instead of $50 because it was a 20% off discount. All right, next up, baseball cleats are on sale for 40% off, and the new price is $33. What's the original price? Once again, start with our P times of equals is. When we do a problem like this, what is the percentage that we are actually paying if it was 40% off?
60.
We pay 60%, okay? Because think about it. It was 100%. You take off 40%. So now you can see you are paying 60%. Change that. Some people are having a hard time remembering. Change this to a decimal, and you get 0.6. Now, if you remember, this of right here is the what? The original price. Do we know what the original price is?
No.
No. Look what it asks us. What is the original price? So what should I put there? I'm just going to put an X because we don't know what it is. Equals is. Do you guys remember what the is?
$30.
Okay. The is always going to be whatever the new price was supposed to be. And as you guys just said, the new price is $33. Now we have a problem that we are used to. I want to get the X by itself. How do I get rid of multiply by 0.6? Divide by 0.6 on both sides. Okay, very good. So now we can see the original price was $55. If you go back through and you just kind of reread it, you see they were 40% off. The new price is $33. We want to figure out the original price before the discount. So it makes sense that the original price should be bigger than the $33 it told us in the original formula or problem. So next up we've got think, pair, share. The first one, the discount on a DVD is 50%. It's on sale for $10. We want to know what the original price of the DVD is. So it's going to be very similar to the kind of problem we just did in number 6. I want you and your partner to work and do number 1 together. Okay, listen, as I walked around, I saw a lot of correct answers. Other people, I want you to really look at this and just try to process in your head before thinking of formulas and how to do things and which order things go into. I want you to think about common sense, okay? So this is what it says. The discount on a DVD is 50%. What do we know about 50%? Half, okay? So listen, it's on sale for $10. When things are on sale, we're happy about it because the price was lowered. Now it asks me what's the original price. So the original price, should it be bigger than $10 or smaller? Bigger. It should be bigger because $10 was the sale, okay? So just think in your head, whatever my answer is should be bigger than $10. Now, with it being something as simple as 50%, I would hope that you could kind of process what that would be. But if you can't, I've taught you all the steps that you need to know. P times of equals is. We're going to go ahead and put that P right there. What would the P be?
50.
Okay. 0.5 times of. Remember, of is the original. Do we know what the original price was?
No.
Not yet. So we're just going to put an X. Do we know the sale price? $10. Now we're going to divide by 0.5 on both sides. When you do that, what's the answer? $20. Does $20 make sense? Yeah, because guess what? $10 right here is exactly 50% of the original price, $20. That means it's exactly half of the original price. How many of you got that? Okay, good job. Okay, so here we go. Once again, I saw a lot of people who really got the right answer, a few other people who messed up on a tiny part. So here's the deal. A store pays $70 for a bike. What's the selling price when the markup is 20%? Here's what I want you to remember. Whenever you're doing a markup, you are putting the percentage in as is. Okay? They're only marking it up by 20%. So 0.2. A lot of you guys put in 80%. You don't want to do that. Once again, markup, if you look at our notes, it says to put it in as the actual given percent that it was given to you. So if you mess that up, that's okay. Just kind of erase it, okay, and fix it. The original price was $70. When we multiply that out, you will get $14. Is the selling price $14? No. What's this $14 right here?
You have to add it.
The markup.
That's just the markup. So now I heard a few of you saying we've got to add that to whatever the original price was that the store paid. The store paid $70. We are marking it up. So now, guys, what is the selling price?
$84.
$84. All right, so I want to do just one review problem because the first couple problems of your homework are going to look like this. This is what it says. Identify the percent of change as an increase or a decrease, then find the percent of change and round to the nearest tenth of a percent. So let's just imagine you had something, it was 15 ounces, and now it's turned into 10 ounces. Once again, I know this isn't in your notes. Just go ahead and write this as the original problem for number 3 directly underneath your other think pair shares. Does anybody remember, we talked about this yesterday in our review notes, how to find the percent of change as an increase or decrease. Does anyone remember that formula? Hunter?
Is it P over O of time?
Okay, very good. It is the AOC, the amount of change, over the original. So just remember, I always want you guys to go ahead and put that formula first. So let's put the formula first. The first thing we've got to do is find the amount of change. If something was 15 ounces and now it's 10 ounces, can you guys figure out how much it changed?
5.
It changed 5. How'd you figure that out? You subtracted. Okay, so we took the bigger number, 15, we subtracted the smaller number. That's going to be my amount of change. As he just said, the amount of change is 5. What was the original amount that our problem started with? 15 ounces. So we're going to divide it by the original amount, which means we're dividing this one by the original amount. When I reduce that, I can see, okay, that's a third. Guys, what is that as a decimal? 0.3 repeating. What does 0.3 repeating mean?
0.333.
Okay. You've got a whole bunch of 3's in there that could go on and on forever. Now, I've got to change this to a percent, so I move my decimal 2 places to the right. Now, going back to the instructions, it says round to the nearest tenth. The tenths place, please remember, is directly after the decimal point. So this one asks that one, are you 5 or bigger? He says no. So what is my answer?
$33.
33 to the nearest tenth. Point 3. Okay, percent. All right, so listen, someone asked, how do you round? This is the tenths place because it's directly after the decimal point. Remember, with rounding, all this one does is it asks its neighbor right here next to it, are you 5 or bigger? Because the 3 was not bigger than 5. My tenths place stays exactly the same. It does not have to get bigger, okay? Now, the final thing that it asks is, tell me whether it increased or decreased. Going back to this problem right here, something was 15 ounces. It ended as 10 ounces. Did it increase or decrease in size? It decreased. It got smaller. So my answer is 33.3% decrease. Once again, your first 2 homework problems today are going to be almost identical to this last and final problem. So right now, I want you guys to go ahead, pull out your homework. I'm going to give you a few minutes. Tonight, there's just 9 problems.